Let's look at our first topic in this lesson, topic A, understanding logistic regression. Logistic regression is one of the most widely used classification methods, and it works well when data is linearly separable. The objective of logistic regression is to squash the output of linear regression to classes 0 and 1. Classification problems are the most common type of machine learning problems. Classification tasks are different from regression tasks in the sense that in classification tasks, we predict a discrete class label, whereas in the case of regression, we predict continuous values. Another notable difference between classification problems and the regression problem lies in the choice of performance metrics. With classification problems, accuracy is commonly chosen as a performance metric, while root mean square is quite common in case of regression. The following figure illustrates how a supervised classification task works. As a supervisor, we provide the model with the variables x, y, which lets the model calculate the parameter theta. This parameter is learned from the training data and is also termed as a coefficient. X includes the explanatory variables and y is the target label that we provide to the model so that the model learns the parameters. Using this, the model produces the function h theta, which maps input x to a prediction h theta x. Classification problems can generally be divided into two types. Binary classification. The target variable can have only two categorical variables or classes. For example, given an image, classify whether it's a cat or not a cat. Multi-class classification, on the other hand, the target variable can have multiple classes. For example, given an image, classify whether it's a cat or dog or rabbit or bird. In case of linear regression, our function would be as follows. Equation of linear regression. Here, x refers to the input data, y is the target variable, and m and b are parameters that I learned from the training data. Also, the cost function in case of linear regression, which is to be minimized, is as follows. Linear regression cost function. This works well for continuous data, but the problem arises when we have a target variable that is categorical, such as 0 or 1. When we try to use linear regression to predict the target variable, we can get a value anywhere between minus infinite to plus infinite, which is not what we need. With logistic regression, we still use the linear regression formula. However, we will be squashing the output of the linear function to a range of 0 and 1 using a sigmoid function. The sigmoid function is the inverse of the logit function. Squash the output of the linear equation as follows. Squashing output of linear equation using sigmoid. Here, we take the output of h theta x and give it to the function, which returns the squashed function to the range of 0 to 1. We had so much theory here, so let's go and do an exercise to understand this better. Welcome to the exercise of plotting the sigmoid function. In this exercise, we will plot a sigmoid function using values generated from minus 10 to plus 10. This exercise will tell us how a sigmoid function behaves and what it looks like. It gives the idea that even though logistic regression uses a linear regression equation, which can give values between minus 10 to plus 10, a sigmoid function squashes the output to 0 and 1. We imported matplotlib and numpy libraries. Now we defined a function, sigmoid x, that constructs a sigmoid function, as you see on the screen. So with this code, I generated values ranging from minus 10 to plus 10 using the following code you see on the screen. And you will get an output showing you the list of data points generated. Now we called the sigmoid function and plotted it. Your plot also should look like this. With this code, we also plotted the values of z using the linear function 0 plus 0.5 times z as follows. And this gives us the following plot. From the preceding graph, it is evident that the sigmoid function squashes the values -10 to +10 to between 0 and 1, whereas the linear function is unable to do so. Let's turn back to our lesson and keep learning. The cost function of logistic regression can be defined as follows, which is obtained using maximum likelihood estimation. After converting our cost function for logistic regression to a linear term, we finally get the following equation. The optimized logistic regression cost function is given here. Note that the derivation of the cost function is out of the scope of this course, and we recommend students to go through the derivation separately. So let's go and do another exercise now. Loading, splitting, and applying linear and logistic regression to data. For this exercise, you will be using the exam score.csv dataset placed in the lesson 7 folder that we downloaded into our computers. The dataset comprises scores obtained by students in 2 subjects. It has also a column that has 0 and 1 values. 1 indicates that the student has passed the exam, whereas 0 indicates that the student has not passed the exam. Your teacher has asked you to develop a machine learning model that can predict whether a student will pass or fail. Apply linear and logistic regression to predict the output. You will also see why it's not a good idea to use linear regression for this kind of classification problem. We first imported pandas, numpy, sklearn, and matplotlib. Now we read the data to a pandas data frame named data and looked at the first few rows. You should also get the following output. And I think now you should be familiar with this step. We splitted the data into training and testing sets as follows. And now we fitted the model using linear regression. And what did we do with this line of code? We predicted on the test data. And here you can see our output. And with this one, we check the actual target values using ytest2. Your output should also look like this. Here we plotted linear regression curve. Your plot also should look like this. From the plot, you can observe that linear regression was unable to predict the values as 1 and 0. Therefore, the model is not able to distinguish the classes correctly. Now let's try using logistic regression. Okay, we fit the model using logistic regression as follows. Now we're going to predict on the test data. You should also get the following output. Now we're going to check the actual target values with ytest2. Now it's time to plot the logistic regression line. Alright, your plot also should look like this. From the plot, you will observe that logistic regression was able to predict the values as 1 and 0. The graph shows that the model was able to classify most of the data points correctly, but some were misclassified. Logit predict probe A can be used to predict probabilities instead of classes.